Hi, let's discuss how to calculate the sample size, which is otherwise denoted as n in statistics. So, we may know that we want information for a certain population, but that number may be too large. So, for that reason, we decide to just take a portion of it and get the information from a sample, which is a true representation of our population. But how do we know how many persons we need to collect this information from? That's our N. Here's the formula for calculating N, the sample size. Please note that this is not a new formula. This is the same formula which we used to calculate the margin of error of our sample means in the previous video. And this is taking our z critical and timesing it by our standard error of the mean. Now, once that formula is transposed, the standard error of the mean is actually the standard deviation over the square root of n. So taking that second version of the formula and transposing it for n, we would realize that we can calculate our sample size by squaring our z critical, timesing it by our standard deviation all square, and dividing it by the marginal error of the mean all square as well. Okay, so that leads us to a two-step approach for calculating n, and this is based on the assumption that the standard deviation is known. Step one, we're going to find our z critical. And if we don't remember how to find z critical, it might be the perfect time to go and watch the video I posted about computing the confidence interval when the standard deviation is known, right? We used the whole table. I gave you a cheat sheet as well with how to get the z critical. And secondly, you're plugging the values into the formula. Now here's an example. What should be the sample size needed to construct a 90% confidence interval to estimate the average math test scores for the student population at Gate High School, given that the standard deviation of the population is 1.4 and the margin of error is 0.3? Please understand that if you're not given the standard deviation of the population, then there's another formula that you would use for that. And if you're not given the margin of error, then based on the information that we have, most times you can calculate. Now, my solution is handwritten, and once again, it is handwritten because I want you to pause and I want you to note this in your notebooks. I want you to accurately write. I can't emphasize how much there is power in writing. It leads to comprehension. So the first thing I did, I started out with what we knew. What do we know? We know the standard deviation is 1.4. We know the margin of error is 0.3. And then we move into our two-step approach. Step one, we're computing z critical. We're dealing with a 90% confidence level, and this is telling me that I have a 10% significance level, and I'm imagining the normal distribution curve, and I'm seeing 0.9 in the middle, and I'm seeing 0.05 towards the two ends, because that will add it up and make the area under my curve 1. When I go to my cumulative probability standard deviation table, I look for the area to the left, which is 0.9 and one of the 0.05s. So I'm looking for 0.95, and my z critical is 1.645. That's also in the video I posted about computing confidence interval with the standard deviation known. And then we're just plugging these values into the formula. So our formula says n is equal to z critical all squared times our standard deviation all square divided by our margin of error all squared. When I put that information in the formula, I get an answer of 58.93. Now, I don't know about you, but I don't know 58.93 students. So if I wanted to sample using a survey, you always round up. I would survey 59 students. That's a good sample to get me as close as to get me information as close as to the population that I'm looking for. Here are your tips for calculating and your sample size. 1, read your problems and document what you know. 2, remember, it's just a simple two-step approach. 3, the assumption here is that we know the confidence level and we know the population standard deviation. Thanks for watching. Bye.